present Latent-NeRF for shape-guided generation of 3D shapes and textures. This work was done by Gal Metzer, Elad Rickardsson, Or Patashnik, Raja Jiris, and Daniel Cohen-Or from Tel Aviv University. The score distillation mechanism, recently proposed in DreamFusion, has shown that one can utilize 2D diffusion models for text-guided 3D shape generation. However, the proposed solution in DreamFusion operates in RGB pixel space and is not suitable for latent diffusion models like Stable Diffusion. We show how to adapt score distillation to latent diffusion models by representing the 3D scene using a Latent-NeRF, which is a NeRF model that renders 2D feature maps instead of RGB images in Stable Diffusion's latent space. This is important because rendering feature maps instead of images allows using Stable Diffusion directly as the score distillation critic on the NeRF outputs, and only use the decoder of the LDM at inference for the final RGB image. Here you can see a few results using our methods. These scenes are represented by Latent-NeRF models, which were trained using score distillation in latent space. In addition, we also show that our NeRF model can be easily adapted to RGB space without leveraging a decoder with a simple linear map. This is useful when we want to fine-tune the Latent-NeRF representation in RGB to improve finer details that can only be represented in high resolution. In this setting, the rendered image is first passed through the encoder before score distillation is applied again in latent space. Next, we show that latent score distillation extends beyond 3D shape generation and can actually be used for 3D texturing of a given mesh. This is done by using a latent texture image instead of a regular RGB image that is rendered to produce feature maps that are trained by score distillation in latent space. Finally, the latent texture image is passed once through the decoder to obtain the final corresponding RGB image. Here you can see the training progression of a given texture image. And here are some additional results using different seeds. Observe how the same input mesh is colored in different styles corresponding to the different guiding text prompts. At last, inspired by both applications, we propose an extension to Latent-NeRF with a weak shape IO, which is able to provide guiding shape controllability over the generated shape. More specifically, we take a guiding shape as input, referred to as a sketch shape, and generate Latent-NeRF models guided by both coarse geometry and text. We achieve this guidance with the help of an additional loss term that encourages points well within the shape to be occupied and points well outside the shape to be unoccupied, while allowing the guiding text prompt to set the tone near the surface. Here you can see a few results that share the same underlying sketch shapes guided by different text prompts. Observe how the coarse geometry is governed by the input sketch shape, while the final details correspond to the guiding text prompt. Thank you for listening, and please check out the paper for more information.